Hi, welcome back to Music Chemistry. This is acid and bases and pH lesson number 6. The first problem is a little tricky. It says the pH of an aqueous solution is 1.5. Calculate the OH ions and the H3O hydrogen ions. Okay, concentrations. Well, what we're going to have to do is we're going to have to use a different kind of formula here. We're going to use we're going to take pH equals the negative log of course, our hydrogen ion, right? Now, watch what I'm getting ready to do here. I'm going to make this log, okay, H3O positive equals negative pH. So what I'm going to do is I'm going to plug in that 1.50 there. So log of the hydrogen ion is going to equal negative 1.50. Then I'm going to do the analog, right? So H3O positive equals the analog my calculator of 1.50. And that, well, negative 1.50. And that should take care of the issue. When I do that, I get my H3O ions to equal 3.2 times 10 to the negative 2. Now I know that, then I can do the rest of the problem. So that's my H3O ion concentration. So I found the first one. So let's find the second one. And we do that by using this formula. H3O positive, OH negative equals 1.0 times 10 to the negative 14 m squared, which is this guy right here. All right, so now we're going to plug in 3.2 times 10 to the negative 2 to give me my OH. A little bit more complex than the problems we've been doing, but it's working out just nicely. Yeah, I know that 14 looks horrible, but so we're going to come back up here to finish it. So the OH minus is going to equal 1.0 times 10 to the negative, let's see if we can make it better this time, 14 m squared, there we go, divided by 3.2 times 10 to the negative 2m. Cancel those out, and now we're going to get our OH values here. Pretty darn snarly, huh? So our OH value is going to be, all right, let's see, we're going to get 3.2, pretty cool, 3.2 times 10 to the negative 13m. All right, so now let's look at the next problem. Now that we got that solved, we have the pH of a solution is 12.0. What is the OH3 concentration? All right, so what we're going to do is this. We're going to again take the formula. pH equals negative log of our H3O, and we're going to make this, we're going to flip it around, and we get log of H3O positive equals negative pH, right? So then we're going to go log of H3O positive equals negative 12.0. Alright, let's just slow down for a moment. So now we're going to take the analog. So we're going to go say, okay, H3O positive is equal to the anti-log of negative 12.0. And when we do that, we get our concentration to be our H3O hydronium ion is going to equal 1.0 times 10 to the negative 12 m. And that's a solution to that problem. Pretty cool. I know it's a little scary, but you guys can do it. All right, let's look one more to help you out here. The pH of a solution is 5.0. What is the hydronium concentration? Okay, again, we're going to start off with our formula. pH equals negative log of our hydronium ion, right? Okay, no big deal. But we know the pH. Ooh, so what can we do? Well, that's not a big deal. We simply go log of our hydronium ion equals negative pH, right? So we go log of H3O positive yields negative 5.0. So now we're going to take the log of that, which is the group. Actually, we're going to take the analog. When we take the log over the equal sign, we make the analog. So this is going to be the anti-log of negative 5.0, which is going to give us our new concentration, which is going to be H3O positive equals 1.0 times 10 to the negative 5th molarity. Pretty darn snarly. I know this lesson was a bit interesting, but we got through it. And you guys be cool and snarly and awesome. And we'll see you back here at Moosine Chemistry.